When the land was first purchased, the vision was ambitious. A full basement beneath the house, complete with a sauna, gym, and workshop. Reality, however, had other plans. Waterproofing and drainage for a proper basement came in at roughly 1 million rubles, far beyond budget, so that idea was shelved. Still, some underground storage was essential, particularly for preserving garden produce over winter. The compromise was a 4 by 5 meter cellar built from brick and cinder block, with extra clearance left around the outside for ease of access. As the project unfolded, nothing went entirely according to plan. Eventually, once the build was complete, the space would be repurposed as a workshop. Throughout the project, cost was a constant concern. Rather than paying retail prices for materials, a long-standing trusted supplier was identified and sourced for the bulk of what was needed. An informal barter arrangement was also struck to bring in an excavator, sparing the owner the exhausting prospect of digging entirely by hand. After the machine completed its work, roughly half a meter of soil was manually cleared around the perimeter using a shovel to improve drainage and allow freedom of movement during construction. The clay soil proved particularly stubborn, hard and unyielding when dry, and an extra full day was spent leveling the base. In the end, due to accumulated measurement errors, the cellar came out slightly undersized at approximately 4 by 3 meters, rather than the intended 4 by 5. The dense soil was difficult to lift and haul out, adding yet another day to the schedule. A drainage sump was also planned for the corner of the cellar. While the exact depth of groundwater remained uncertain, a ventilation system and a submersible pump were earmarked for installation as a precaution against seasonal water ingress. Roughly 900 recycled bricks salvaged from a neighbor's demolished home were used to construct a fixed formwork and a modest foundation to support the future walls. Rain mixed with the clay to create muddy, slippery conditions inside the pit, so leftover asphalt offcuts were spread across the floor to create a more stable working surface. With the foundation in place, the next task was waterproofing the base. Standard roll waterproofing material was cut into manageable sections, laid in overlapping layers to prevent seepage. Applying the material with a blowtorch was a new experience. The gas ran out midway through, requiring a backup canister, and the first few hours were something of a trial run. By the end, though, the technique was well in hand, and the seal felt solid and reliable. From there, non-removable brick formwork was constructed along the perimeter to hold the concrete foundation pour. Bricks were specifically chosen over timber to avoid puncturing the freshly laid waterproof membrane. An improvised chute fashioned from old pipes was rigged up to channel the concrete down into the formwork without risk to anyone working below. With both owners working together, the foundation pour was completed in around 3 to 4 hours. Planning the staircase required careful thought. The entry point was to be positioned above the stairs, feeding into a future workshop area, which meant the staircase had to descend the full 3-meter depth of the basement without being dangerously steep. An initial sketch for a simple hatch access box was quickly abandoned. It would have been noisy and awkward. Planning the staircase required careful thought. The entry point was to be positioned above the stairs, feeding into a future workshop area, which meant the staircase had to descend the full 3-meter depth of the basement without being dangerously steep. An initial sketch for a simple hatch access box was quickly abandoned. It would have been noisy and awkward, especially as the owners aged. The decision was made to build a proper, comfortable staircase from the outset. Two significant challenges had to be navigated. First, the clay ground was exceptionally tough to excavate. Second, the basement was 3 meters deep, demanding a long staircase run. There was also a property boundary to respect. Ideal step proportions, 16 centimeters rise, 30 centimeters tread, would have pushed the bottom step into the public road. Instead, the steps were adjusted to 20 centimeters high and 25 centimeters deep, trimming around a meter off the total run. Excavation for the staircase initially produced 5 rough earth steps, each about 40 centimeters tall and 60 centimeters deep, cut at roughly a 45-degree slope. Old, wide boards found on site were used for the side formwork. 3-meter lengths extended out to 4.5 meters to accommodate the full staircase profile. The triangular structure had a base height of 3 meters and a diagonal span of 4 meters. The staircase was set at 1.2 meters wide, with 20 centimeters walls on each side, bringing the usable interior width to 88 centimeters, comfortable enough for regular use. Plastic sheeting was stapled to the side formwork panels to keep moisture from the ground from contaminating the concrete mix. 5 sections of road mesh, welding mesh, were purchased at 200 rubles each and laid in for reinforcement, along with 7 pieces of rebar spaced 15 centimeters apart. The mesh was bent above each step to maintain a minimum 5 centimeters cover from both the side panels and the surface, critical for structural strength, since any exposed metal would weaken the finished staircase over time. To avoid wasting concrete on the upper threshold section, iron angles were inserted to partially fill the void, and a few loose bricks were placed to help support the mesh and rebar in position. A homemade trough was knocked together from spare boards and iron beams to feed the concrete mixer efficiently. The pour itself was a joint effort, one person mixing and pouring, the other smoothing and finishing. A concrete vibrator was used thoroughly on each step to eliminate air pockets. The mix was a standard ratio of 1 part cement to 3 parts sand to 5 parts gravel, with the addition of a plasticizer and polypropylene fibers for added strength. Despite the operation taking 13 hours, there were no cracks, no leaks, and no significant problems. 8 days after pouring, the surface was worked over again to achieve a smooth, glass-like finish. The formwork was stripped 3 days after the concrete had fully The original plan called for cinder block walls, and the foundation trench had been dug half a meter wider on each side, specifically to allow room to lay them up. But affordable cinder blocks in the right dimensions simply could not be found locally, so poured concrete became the new approach. Because the basement footprint was not a perfect rectangle, a consequence of the original plan having never accounted for formwork, a supporting timber framework had to be constructed first. Vertical posts were positioned every 30 to 40 centimeters and braced at top and bottom. The lower ends of the braces were buried in the ground for stability. The upper ends were pegged with wooden stakes. Getting all the supports plumb and level took 2 full days. For the wall shuttering, old corrugated roofing sheets salvaged from a neighbor's recently demolished house were used as the facing material, backed by additional horizontal bracing cut from leftover timber. Steel reinforcing rods were drilled and inserted at 50 centimeters vertical and 30 centimeters horizontal spacing. Not the ideal arrangement, but appropriate given the budget. Fiberglass mesh left over from a previous job was also woven in for additional tensile strength. When timber ran low, a batch of second-hand construction wood was sourced via a local classified ads platform. The corrugated sheets were held against it with sheets of waterproof plywood that happened to be in the mix. These turned out to fit the formwork almost perfectly. When the concrete was finally ordered, the initial delivery proved insufficient and a second load had to be called in. As the pour progressed, any point of formwork showing signs of strain was immediately reinforced with extra bracing. By the end, the walls were solid, dense, and highly resistant to water ingress. With the walls poured and cured, the external formwork had to come down before waterproofing could begin. Stripping the shuttering took longer than expected. The panels had not been fully fastened to one another, so dismantling was unpredictable and awkward. Some sections were buried deep in the ground, and the whole operation stretched to over 2 hours. Once removed, the area around the basement was tidied up. Protruding nails and loose boards were cleared away, and some soil was pushed back against the base of the walls to create a safer and more comfortable working platform. The temporary oilcloth waterproofing layer and the top course of slate were then stripped off. Some sections peeled away cleanly, others needed gentle heat from a blowtorch to release. Removing this layer was essential so that the bituminous mastic could bond directly to bare concrete rather than to a loose surface. The mastic was prepared by thinning it with acetone or kerosene until it reached a consistency similar to paint, then heating and stirring it until smooth and workable. It was applied using both a roller and a brush. The brush proved more effective for working the material into pores and fine crevices, especially important since the mastic begins to stiffen quickly once it contacts cold concrete. For the roof of the basement, a thicker version of the mix was used to build up a layer approximately 2 to 3 millimeters thick. The full application comprised 2 coats for thorough coverage. For insulation, extruded polystyrene, XPS, foam boards, specifically 50 to 60 millimeters Penaplex panels, were chosen. Before purchasing, the manufacturer's technical support line was consulted on two key questions. First, whether the boards would resist moisture and fungal growth in an earthen environment, and second, whether they could be successfully bonded directly to bituminous mastic. Both questions were answered positively. One important caution was noted. Cheaper expanded polystyrene should not be used in contact with bitumen-based products, as the solvent content can degrade the foam over time, eventually leading to water infiltration and frost damage on the basement ceiling during winter. The boards were adhered to the ceiling and all four walls using foam adhesive rather than mechanical anchors, which greatly sped up the installation. Any joints or gaps between panels were filled with additional expanding foam to eliminate thermal bridges. Installation went quickly, and the result was comprehensive coverage across the entire basement shell. Once insulated, the space was ready to be covered over. Starting from the corner farthest from the planned workshop, bricks were laid on top of the insulation to weight it down against the pressure of the incoming fill. The excavated clay was then moved back into position, a formidable task, given that the basement measured approximately 3.3 by 4.1 meters, and the volume of earth amounted to somewhere between 36 and 50 cubic meters once settling was accounted for. With no budget for a tractor or a hired crew, all of it was moved by hand using a wheelbarrow over the course of several days. Late autumn was closing in with rain and early frosts, adding urgency to the work. Plans were made to bring in a truckload of topsoil in spring to dress the finished surface and establish a lawn above the basement. Roughly 4 weeks after the interior ceiling and floor formwork had been poured and set, the time came to strip it and reveal what was underneath. Before starting, a new jigsaw, dust extraction capable, and a laser level were added to the toolkit, both considered essential for the phases ahead. Armed with a sledgehammer, screwdrivers, and a crowbar, and with a safety helmet firmly in place, the dismantling began. The timber props came away without too much trouble, but the steel ones were significantly harder to shift. The weight of the structure had compressed them, and they had to be wrestled free. A key lesson emerged. Formwork should ideally be stripped within 3 days of the pour. Left for 4 weeks, the concrete had fully bonded to every surface, making removal far more laborious. The internal clamps had drawn the components tightly together, and areas where plywood had been used without an oilcloth release layer adhered stubbornly to the concrete. Where the oilcloth had been applied beneath the plywood, however, the panels separated easily and cleanly. Working methodically, starting at the stairwell where sections were smaller, the formwork was gradually dismantled piece by piece. With everything finally stripped, the raw concrete walls were exposed for the first time. Though the surface appeared rough, the underlying structure was sound. Fans were set up to dry out any residual moisture, and plans were drawn up for the next phases: fitting doors, tiling the floor and walls, and wiring the electrical system. The project as a whole had delivered hard-won lessons in excavation, concrete, waterproofing, insulation, and the importance of working with quality materials. Every unexpected challenge had been met and overcome, largely through resourcefulness, patience, and no small amount of physical effort.